Hello everyone, welcome to section 3.6, which we're going to talk about graphs of functions. So it's a short section, but we're going to introduce the vertical line test and then identify basic graphs. So let's get started. First of all, what's the vertical line test? Vertical line test is an easy way to tell using a graph if something is a function or not. Remember what our definition of a function is. So for a set of points in a domain, a function is a relation where every single point in the domain points to a unique point in the range. So let's say, for instance, remember we said that the x, if we had a list of points, the x does not repeat. So if you had points like, let's say if you had, sorry about that. If you had, let's say, points 1, 2, and points 1, 3, this would be not a function because you would have in your domain, you'd have this point 1 where it points to, or it maps to two different points, 2 and 3. So that's the definition of not being a function, right? So it's okay for multiple x's to point to the same y, but you can't have one x pointing to a different y. And that has to do with the fact that, you can kind of see a function as like a little machine where you have an input and you take out exactly one output. Okay. But we're going to get more into that later. So anyways, the vertical line test is an easy way to tell if something is a function or not, because you have your graph, not a drawing graph. Well, I guess. And you just draw basically vertical lines. If it only crosses once, yes, it's a function. If it crosses more than once, here and here, for instance, or, let's say here, right? It crossed more than once, so it's not a function. And it makes sense because let's say here it crossed at points 3, 2, and here points 3, negative 2. So see, the x repeats, you have two different values, you have two different outputs for the same input, so this is not a function, okay? Let's see here. So we know that the graph of a function is basically the set of all its ordered pairs, or the pairs that fulfill it. You have the input, the output, or x and y, or you can also think of y as f of x, right? The function evaluated at that point x. So now we're going to get into a couple of basic functions here. So linear function, it's y equal mx plus b, or if you're going to use the proper notation, f of x equals mx plus b, where this is the slope, the m is the slope, b is the y-intercept, or where it crosses the y-axis. Okay, so here would be b, and then this would be our m, the ratio of rise over run. Linear functions have a domain. They go out to negative infinity and they go out to positive infinity, and then the range is also negative infinity to positive infinity. Okay, yep. So if I want to graph here, let's say negative 2x minus 4, I start with the y-intercept, right? I have my function here. I know that just by looking, the coefficient of x is negative 2, and the b, or the constant part of that line, is negative 4. So that means it's going to cross the y-axis here at negative 4. And then the slope is negative 2, so rise over run, right? So negative 2 can be thought of as negative 2 over 1, or you can think of it as 2 over negative 1. In any case, you know how the slope is rise over run. So that means that if I look at it this way, it's going to go down 2 and to the right 1, starting at here. So down 2 over 1, draw a point, down 2 over 1. Okay, so then you just draw your line through here. If you want to go in the other direction, you could also have thought of it as 2 over negative 1, which would mean that it goes up 2 and to the left 1. So starting from here, up 2 to the left 1, up 2 to the left 1. Oh, okay, I didn't draw it perfectly right there, so let me just fix that. It's a little bit more steep. Okay, yeah. Okay, so that's it. I know it's not perfect, but you guys get the idea. All right, how about the constant function? So the constant function is a line, a horizontal line, where there is no slope, right? So it's basically just y equals a number, or f of x equals a number. and where b is any real number, also the y-intercept. The domain is negative infinity, infinity, because you can see that it goes out all the way to the left and all the way to the right, infinity. Remember, the domain is all the possible x values that the graph can contain, and then the range is just one value wherever it crosses, right? Because range is a set of all y's, and in this case, y is always b, you know? So let's say here we have f of x is equal to 4. In order to graph that, all we have to do is find 1, 2, 3, 4, okay, and then draw a horizontal line through that. And that's our constant function. Some other functions that are popular that we should start getting to know and make friends with is the identity function. That's just y equals x. It goes through the origin. It has a slope of 1, you know, up 1 over 1, up 1 over 1. Okay, the domain and range, of course, are from negative infinity to positive infinity, and you can see that because it goes out to negative infinity and positive infinity in the x direction, and then down to infinity and up to infinity in the y direction. Okay, all right. Square function, y equals x squared, is also one to get to know. That's a parabola, also known as a parabola, and it's like a U, you know, like little upside down horseshoe or something, where it extends up to infinity, you know, goes out and up. And then as x increases, you're squaring it. So, you know, 1 times 1 is 1, 2 times itself is 4, and so on. Now the range, it starts at 0. See, there's no graph below 0, so there's nothing here. No graph here. The graph begins here and goes up. So the range is from 0 to infinity. And since it opens outwards, the domain is from negative infinity to positive infinity. Cubic function, x cubed. Domain is the same, negative infinity, as a line, negative infinity to positive infinity, and the range is the same because it opens outwards. Square root functions, also very popular. Square root of x. You know, it starts at 0, 0. You can't take the square root of a negative number. So we just go from 0, 0 and on, and as x increases, y also increases. The absolute value function looks like a v, okay, where it takes the identity and then, you know, makes it positive, right? The output is always positive. So notice that the range goes from 0 to infinity, and the domain goes from negative infinity to positive infinity since it opens outward in those two directions. Okay, so let's see if we can find the domain and range using a graph now. And I'm going to let's see if I can do this here. A little, yes, I'll try this here. Okay, so I'm going to create this little rectangle to kind of illustrate something. Okay, let me move that here. So first of all, if you have a function and you want to find its domain and range, okay? So let's say we have a function here and we want to find the domain of this function. Now, you take you can take a pencil, but in this case, I'm just going to use this bar, and I'm going to go hold it vertically against the graph, and then just go left to right, and then see where the graph begins. So then here I can see that in the x direction, going from left to right, the graph begins at -3. So the graph begins here at x equal -3, and it continues, oopsies, the graph continues up till +3. So, you know, here, it stops here at x equals +3. So the domain is from -3, it includes -3, sorry, to +3, and that's the domain, okay? Now, if you want to do the range, I'm going to use a different color, I guess pink. Okay, fine. Let's see, let's twist this thing, okay? Now, if you want to do the range, hold your pencil horizontal and then go up and down, okay? So here's my quote-unquote pencil, and I'm going from the bottom. Okay, there's no graph, no graph, no graph, no graph, no graph. Here's where the graph starts. It starts here at y equals -1, and then continues and continues and continues up till y equals 3, okay? So this part, it goes up to here, y equals 3. So the range is from -1 to 3, okay? Let's do another one. Let's use this graph to find indicated value. So let's do a little bit more here. So this example is a little bit more involved. So let's say we have this graph, okay? It looks like it's the sine function, but don't worry about that. You need to be able to find certain things. So let's say, for example, A, we want to find f of 0. So here's x equals 0. The function at 0 is equal to 0. So for A, f of 0 is just equal to 0. They want the y values when x is 0, right? So this tells you x. And it basically, when you see f of like that, f, and this means, hey, what's y? What is the y value or the output when x equals something? You know, if it has a number, let's say this has a number. Okay, so here the input is 3/2 pi. So then you go, okay, where's 3/2 pi? It's over here. Oh, when x is 3/2 pi, the output is -1. So f of 3/2 pi will equal -1. Okay, then f of -1/2 pi. So right here, see, the output is also -1. So f of -1/2 pi or negative pi over 2, same thing, is equal to -1. Now it says find the values of x when the graph output is equal to 0. So in other words, where does the graph cross the x-axis, right? So it crosses here, 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 and here, and here. So for D, your x values would be -2 pi, pi, 0, pi, and 2 pi. Okay. What about E? That's the same thing as the x-intercepts. So E, see this, same as D. Okay. F, find the y-intercept. There's only one at the origin. Okay, it's right here. It's the only place it crosses the y-axis. Okay, find the domain. It looks like it goes open. It goes from -infinity to +infinity. Okay, and then the range, last part, notice that it only goes, the lowest point is here, right? Down here. So here at y equals -1. But then it goes up all the way to y equals +1. So that's it. There's nothing else. It doesn't go any higher than that. Okay, that's it for 3.6. Here is your super fun homework. Good luck, and I will see you on the next video. Good luck on your upcoming exam. You can do this. Make sure you make time to review using Newton. It's the review, of course, it's not for credit. It's just for you to practice. I would highly suggest, making time to do that before you actually take the exam. Okay, good luck. Happy studying, and I'll see you in the next video.